And we're live. Hello world. Today's a really early stream. It will also be very brief because I have somewhere to be in an hour, and I am occupied for most of the evening. So, yeah, I'm gonna need to be rather quick today. This is day 201 of studying compilers every day until I land a compiler role. Last time we did a big compiler optimization taxonomy thing for like day 200. That was like kind of fun. Um, yeah, this time we're gonna go back to our big compiler project. We're gonna continue the big rewrite. Yeah, we're just gonna keep working on the plumbing, and hopefully we make some progress. I don't really have a goal on how much progress I make today. I just want to make some semblance of forward progress, and I think that will be pretty good. Maybe if we figure out like all of this like all this expert stuff, it would probably be nice. I think that would be a pretty cool state to be in. But yeah, let's get straight into it. So, I think terminal is fine and parent is fine. Call we probably need to do some more stuff with. I think we could go back to unary. I think this is probably a good place to start looking again. So we did a little bit of generation here, so we can kind of copy most of this over in some way. Yeah, I guess what do we even need to generate, right? We want to make a. I guess we should nuke some of this. Maybe it'd be easier to start with the call expert. So what goes into a call? I think this was like relatively straightforward, right? We just need to like generate a little bit of boilerplate, but it's not that bad. Where does this live? And we also wrote a bunch of helpers last time, so that'll help significantly. Okay. So we want to make, I guess we specifically want to make like a call instruction and then assign the result in some way. Yeah, okay. So we need to make a temporary, I think. But that's like really annoying. Maybe we should make a helper for that. I guess we don't really need to make a helper because we are like SSA now in a way. So let's see. What do we even do? So auto, I guess. Oh boy. I guess we kind of do something like that for return, right? So we, or no, we already have a temporary there though. I guess we want to make an allocate regardless. So we want that. What else do we do? Okay, so we want e get collie, I guess. Yeah, so we want to, actually, how do we figure out types for this? I think we had like a big function type map, right? Is that how we got a type? Yeah, we got a type from that. So whenever we parse a function, we necessarily add it to mapping. So that's where that comes from. So we need to store that. Early stream, yeah, we got some stuff we gotta do. So that's where we're at. Yeah, actually, what do we even need to make the call function? Right, call. Okay, yeah. So we need a type, we need a function, and then we resolve that later because it might recursively call itself, and then we need the args. So that's actually not that bad. Yeah, okay, so let's make the mapping real quick. Are you Korean? I'm not. Yeah, this is always a really funny question to get. I am Chinese. Okay. So we want yeah, how do we want to do this? Let's make a map from the calls. Yeah, let's actually, I don't know. What even was resolve functions again? Just resolve function calls, I think. Is that the point of it? No, yeah, you're good. It's, I can't really like it's the internet. I think there are a lot worse things to say on the internet. Yeah, like it is what it is. Wait, so where do we call resolve functions? Wow, we just don't call it? I guess it goes like at the end of our thing, right? So it'd go here. Long job search? Yeah, I mean, it is like a little bit contrived because I have an internship for the upcoming summer, but I haven't really like started looking for full-time, which is, I guess, my condition for this stream series. So, yeah, in that sense, it's drawn out a little bit, but I'm enjoying streaming, so I can't really complain. Okay, so we want to do that over here. Yeah, this makes sense. Doing your intern at a bank? Yeah, it was one of the larger banks that exist, but it doesn't really align with, well, compiler stuff. It's more like web dev / like infrastructure, which is less interesting to me. So, not that it's not interesting. I did still have a really good time, but I don't know. I think it's not a perfect typecast, and I think it would be better if I picked something that aligned well better. Let's see. So where do we call the other thing? The resolve. Okay, that's where we call that. Okay, so we can worry about that later. For now, let's continue doing call. We definitely want like this stuff here in some capacity. Yeah, so let's also, let's see. Let's add a mapping, which is like, I guess we already have this here, which is useful. So we can work with this. So we want function type, or I guess we could just rename it to function types. Yeah, so we can do that. Function types at, we can do, sorry, I'm like dying. Get callee, and then get value. So that helps with that. And then we make an allocate. What's wrong here? Oh, it takes the other type. Oh, that's really annoying. What type is this then? Yeah, this is the front end type. Oh, because we're using it here. So we want AST type, I guess? Is that what we want? Does that work? Yeah, what type is this? Why are you passionate about compilers? I like PL, I like architecture. I think compilers combines those two, as well as a bit of like theory and software engineering. I think those are like the 4 things I like the most about CS. So it's really nice that I can find them all in this one place. I don't know. LLMs feel a little bit full of air to me, at least in the way that they're marketed. I think in that sense, I think if I were to work on LLMs, a lot of the stuff would get like a little too diluted with, I guess, just like media hype. Whereas like stuff that's more like fundamentally systemsy is a little bit more grounded, at least in my opinion. Okay. Oh, what's wrong with this? So this is a front end type. Oh, this takes middle end type. Okay, that's actually not bad then. So this also takes middle end type, so we can just do MIR, I think. Unless we want to just map it to middle end types. I think this is probably better though. Yeah, okay, so then we can do that. So then we have an LK, that's like our temporary buffer. Yeah, so then, let's see, what else do we want? We want to resolve the parameters next. Yes. Oh, yeah, we need one more map here. So from, oh man, middle end, MIR, instruction call. We can do call putter to, what do we want to map it to? What else can we do with call, by the way? We'll figure this out in a second. Let's yoink args from here. Instead of resolving that like that, we'll figure out what to do with it. What's up, Gospel? Yeah, you're unfortunately forced to do a little bit of compiler reading, or at least compiler media ingesting for now. Yeah, okay, so we can set the callee there. So this is fine. So we want to map it to, what are we even mapping it to? 64T, I guess? We're mapping a call to the, I guess, function ID. Oh man, this is actually really annoying. Yeah. Unless we want to do it the other way? Actually, yeah, I like it the other way more. And then a std vector of that. Instruction call star. And this is going to be function, or I guess function calls. Yeah, and we'll do that. Yeah, okay. I like this a little bit more, because then we can just continue pushing it back. So what we want to do here is function calls at we want that whole thing again. So let's actually just do auto callee ID, and then we can yoink that. Yeah, there we go. That's a little bit cleaner. Yeah, so we can split that. We can kind of keep that like that. Yeah, let's move the allocate down here as well, because we also want to store into the allocate pretty much. So function calls at call get. We want to, what's wrong with this again? Yeah, it should work. Oh, wait, I'm doing it the wrong way. So let's do callee ID. So that we want to push back that thing. Like that. There we go. Okay, so now we just need to generate the store. So we have an LK, and then we also want to, where is our store? Or I think we had an example somewhere up here that we could yoink from. Yeah, we can do this. Right? Yeah, so we can do that. Yeah. You can just call this allocate. Or just allocate. And then instead of this, we put in call. Call get, I think? Yeah. Yeah, so it takes an instruction. Oh, that doesn't help me. We'll just assume that this works and pray that it's fine, I guess. It should take a value, and I'm fairly sure this is also a value. Yeah, this extends value, so it's a value. So this is valid. Okay, so we make the store there as well. Also instructions, push back, stood, move, call. Okay, so that makes sense. The only thing we need to do now is clean up the args. What's up, Akash? Have you encountered C or C++ more? This is like really interesting because in compilers, I've mostly encountered C++ stuff just in terms of like most of the infrastructure for a compiler is being built in like C++, or like higher level languages than like C, because C needs a lot of abstractions to do a lot of this. But like the caveat is first, usually the language being compiled is like some variant of C because it maps pretty closely to like assembly. And second, most of my systems classes have also used C more than C++, just because like it's canonical for like operating systems. And then like a lot of the like canonical libraries are also in C. So in that sense, I would say there's been more C just because like there's also been like more systems stuff in general. What's up, Izzer? Good to see you. Yeah, today is giga early, so that's how it will be. Okay, so what type is arg? This is a unique putter of x per arg. Yeah, so then we can just solve. So we want to accept this, I believe. We want to do that to recursively generate that. And then args push back. What type is, yeah, so we can just push back prev expr. Yeah, also we need to set prev expr somewhere here. Yeah, this is annoying. I guess we do need to generate loads for some of this, at least. Wow, wait, this is actually very annoying, the way we do this. I wonder if we can like skip a lot of like explicit load store generation. I wonder if we could be really lazy with this. I guess if we were reusing values, it would be a little bit dangerous, so I probably shouldn't do that, but yeah, actually, I don't know. That's very interesting. Huh. Well, we'll see. Yeah, so we're gonna assume that there's gonna be loads generated for whatever things there are here. Yeah, actually, I don't know how I would do this, to be honest. Yeah, this is very annoying. I guess we would want to load from this then? Is that what we'd want to do? Yeah, actually that is interesting. Maybe generate load. And then push back to args. That's definitely what we want to do here. Yeah, that's the other thing. I don't really know how I would like encode these temporary results, at least. I don't think there's a great way to. What would we encode at least? The putter? I guess I should encode the putter, to be honest. That might be easier. Either the putter or just like the literal value. Yeah, I see why I just like insert a value into something now sometimes. Yeah, I don't know. I don't know what we want to do about this. Yeah, I think C++ will probably be important, unfortunately. I think theory might be a little bit useful. There's a lot of algorithms that require at least some semblance of theory to, I think, properly understand, but you could probably learn that on the fly, to be honest. Okay, let's put the putter or value here, I think. Unless we want to just simplify it to only the putter. I guess that means we need to... we want a helper for that, I guess. Yeah, let's... Let's make a helper. Let's make another helper. Because why wouldn't we want to? So we have make allocate, we have get literal, we have get use. We want mir value star. And this will be load prev expr, I think. Yeah. And then that will be a helper, which should be not that bad. Yeah, we're just gonna clean this up real quick. Okay, there we go. So here, let's see. Wait, what else do we track here as well with the functions, right? We track the types and then we track the calls. I see. Okay, I understand what we do there now. Yeah, okay. Yeah, it is like, I think it's up to you how you learn best, right? Like, I think there's value to be got in both ways of doing it, at least. Okay, so you want literal. So we went to dynamic, cast to literal star. We give it prev expr. And this should be, yeah, and then if literal, then we return literal. Otherwise, you want to I want to make a load. Yeah, sorry if this is like a really messy screen to look at, by the way. I just have like so much reference stuff up at once. I think that's a sign I need to clean up my workflow at some point, but we'll figure that out once we get there. I don't think we have any loads actually that we can yoink from. So we are gonna have to make a load, which is new. Yeah, so let's yoink that. So this is, let's see, what do we want to do here? What's up, Egglover and Panda? Today's early because I gotta be somewhere in half an hour. So I've got like 20 minutes of stream left to make something work. Okay, so this is var types, and then, oh, this doesn't work. Oh no. Okay, we might have to encode like the previous expression type as well, huh? Huh. That is really annoying. Can't we just get the type of the, wait. Yeah, okay, so this will have to be a pointer then, I think. A pointer to the store. So we can static cast to mr, what's it called? Huh. So this is what instruct. This should just be an allocate then. Yeah, so we can do that. So then we can do store get alloc type. And then, yeah, and then this is just like, yeah, we just have store here, so that's perfect. So we have type, and then here we just do store. Neat. So this is actually, I guess this is putter, maybe we should rename it to. Yeah, so we can do that. And then instructions, push back. Move, load. And then, oh man, this is rough. Then we just, oh wait. Yeah, so we want that. Turn load putter. So that's how we want to do it. Yeah, that's so messy. But I guess it kind of has to be that way. Okay, so now that we have load prev expr, we can use that wherever we were. So this is in call. So args push back load prev expr, like that. There we go. So now we generate that, that's perfect. And then we generate a load, and then we put that in the arg, I guess. Yeah, so that's a value. Okay. So I think that's all we need here, actually. I don't think we need this like var types thing anymore, luckily. We might need it. We'll figure it out once we get there. I'm fairly sure we don't, though. So I'm just gonna preemptively delete this, and if we need it, then we can just add it back. What's wrong here? Oh, I accidentally deleted that as well. That's really funny. Okay, we can do that, and then we should be big chilling. So... Okay. So now what we can do... I guess that means we're done with... Wait. Wait a second. Wait, maybe I should have done that in, maybe I should have just done that in, like, Terminal Expert, huh? Maybe not. I don't know. Yeah, let's actually think about this. Figure out... Or... Should we generate a load/store? Okay, parens is like straightforward enough. We just do that. Call we just did. So all that's left really is like unary up and binary up, which will be kind of annoying. I'm gonna go to the bathroom real quick. It should be really quick. We're already pressed on time, but yeah, yeah. Okay, I'm back. We got like 5 minutes. Okay, let's see. What do you even want to do? Something tells me that I should just generate loads in the thing instead of, I guess, just doing stores. In the base expression at least. What's up, Yums? I just built a tool to provide trace of GCC's internal decision making. Ooh, yeah, that seems nice actually. Traditionally, I think like even though like the major compiler tool chains are very modular, they're pretty opaque. So I think like tooling that exposes that is really cool to me at least. Like, have you like ever tried to get like the passes that LLVM runs at like the optimizer level? Like, you got to jump through so many hurdles. So yeah, I think that's a pretty neat tool at least. Okay, I think I want to generate a load in the thing, in the terminal expr. So yeah, I think that's what we want to do. Oh, actually, this is really awkward now that I think about it. Yeah, actually, it is better this way, I think, because we might want to handle like the stuff on the left side of an equals differently, or at least yeah. So let's see, what do we want to do with this then? Okay, I think the way we do it is fine then. Actually, we necessarily should not generate this. So this is just like an atom. So we either have a use. Where is get use? I see. So we just get the binding, I guess. Oh man, that's really annoying actually. Okay, we're gonna have a lot of bugs to work through, I guess, but that's fine. Yeah, we're doing a lot of different things at once, which is, I guess, kind of why I was happy splitting it up into like 2 IRs. But I guess like there were like issues with slicing that at least. Let's see. Yeah, cause like this like get used thing is like really awkward. What is this return at least? Or where does this come from? Okay. So we don't actually write anything to that, which is interesting. Yeah, this is really irritating. Oh man. Yeah, I guess we'll figure out what to do with that at some point. So let's assume the simplest case, if it's just literals, then that should be fine, I think. We just add the values and like we store them somewhere. Or like we do whatever with it and we store it. If it's variables, we only want to generate a load on the right hand side, and that we handle with the what was it called? Load prev expr. Yeah. Let's rename this. What's up, Game Smasher? 3am here. Oh, Python C#. That's nice. I think I think at least talking in front of a camera is one of those skills that you only get better at with practice. So, yeah, I believe in you. I think you don't necessarily have to, but if that is something you care about, then I think you just got to do it more, unfortunately. Does your compiler interpolate into x86? Oh, what's good, John? What do you mean by interpolate? I don't think I've heard that used to describe anything before. Also, I gotta dip in like 4 minutes to go to Aiden's class. Okay, yeah, so we do generate a load there, I guess, which is fine. Does it produce assembly as a string? Yes, insofar as like I store it as a string, at least, and then I like write it to the file. If I'm understanding what you're saying, yes, I think so. Okay, we need to change that because we need to load this. Yeah, so we have a load now, and then we make an allocate for the store. Oh man, this is awful. Where does it do that? It's handled in driver, which is broken for now because I'm rewriting stuff. Yeah, like we read from a file, or that's output. So this is we open a file, write to it, and close. And then over here, yeah, so we read from a file and we preprocess, and then we keep that string, and then we parse it into an AST proper. Oh yeah, we should probably figure out typecasting at some point, but that's a future concern. Actually, how does LLVM do typecasting? Alright, LLVM, IR, typecasting. Yeah, so we have like bitcast and zero extend. We have zero extend, sign extend. Really funny name. And we have truncate. Okay, so there's so many utilities here that I'm gonna need to do. I do need to cast because I need to handle pointers properly. Yeah, I mean it is just inevitable. Anyways, I think we're gonna have to call the stream here today though. So let's add that. Migrate call expert plus write more load utilities. Let's push. Okay. I think that means we do gotta wrap it up here though. I gotta head to Aiden's class and watch his friend present his code. Thank you all so much for showing up today. Apologies that was really short, but we will be back to our regularly scheduled programming tomorrow. If you haven't already, like the stream, sub to the channel, join the Discord, it's in the description. And my GitHub sponsors is also there if you want to give me money. Yeah. Take care, y'all. Take it easy. And I will see you all tomorrow. I will say hi for you, yes.